Hello and welcome to video number 9B on our series looking at the most accurate clock on Earth. I'm calling this number 9B because 9A, which is one I just did before this, has got some big errors in it and I thought I need to correct them. So that will be renamed 9A. The two big mistakes I made was most people picked up that the pendulum was actually swinging anti-clockwise, so it was going in this direction. And the other mistake I made was the pendulum was going anti-clockwise, but the bob was actually going in its launch trajectory. Now what I said was the Earth comes around to meet that. That is incorrect. That cannot happen. It can only happen if the Earth is stationary. So now we have a conundrum. We have this pendulum shows a Foucault pendulum showing the Earth is spinning anti-clockwise, which it should do, and we have incorporated in this, if we're looking from using the bob as a frame of reference, it is now the plane pendulum number 3 is showing the Earth is stationary. So within this one device we have the conundrum of a spinning Earth and a stationary Earth. So let's regroup and go over every step that I've made and see if we can pick up where I've gone wrong or how we can improve the pendulum for future. So I'll just stop and let's regroup. So where did this plane pendulum number 3, how did it happen? Well, if you've been following my experiments, you notice that I picked up on the fact that the actual bob itself seemed to have its own trajectory independent of the pendulum swing. Now, most pendulums you look at are blank, so the bob itself is blank. They're usually shiny, reflective, there's no indexing marks on them at all. So my pendulum, the plane pendulum number 3, let's put a mark on it. Put a couple of marks. Now we've got an indexing mark on it now, so we can actually see what's happening with the bob rather than looking at a reflective shiny bauble that's just dangling that's got no reference. Now what I noticed was, although the pendulum had its own swinging trajectory, either clockwise, anti-clockwise, the bob now we could actually see what it was doing. So the first time I believe that anyone has looked at the bob itself, I started noticing the bob had its own unique characteristical trajectory, which always seemed to be always in line with its original launch trajectory. Now we all got confused in previous experiments because the bob would spin and twist and we never really understood what was going on until I started getting a more accurate launch mechanism, and which was this magnetic launch mechanism I actually introduced. Now what that seems to give us is that we can now launch the bob without this swinging, twisting. We can actually launch it on a specified trajectory and monitor what's happening in relation to the swing. Now if you looked at that previous number 9A experiment, you'll notice that the pendulum was going anti-clockwise, but the bob stayed on its original trajectory. So now let's regroup and go back again. So how do we overcome this problem of aligning the launch angle to a reference angle and monitoring the rotational angle of the bob while it's in flight? Well, it was quite difficult before until I came up with this concept of mounting one of these little gyro chips inside the bob, which I've done here. So inserts that, and we can actually put that anywhere inside the bob. Doesn't have to go anywhere as long as it's flush and concentric to the bob surface, which is very important. Now we have got our extra parameters of angle, roll and pitch. Also I've included the other parameters of the accelerometer. You'll see these on the screen there now. So I'm not only just focusing on angles now, I'm looking at acceleration and angles of acceleration. Alright, let's reassemble our bob, put the bottom half on it, give it some extra weight, and we'll do another run, and let's see what we can find, any solutions to our dilemma. On video 9A, a viewer commented that perhaps the bob is tracking to its original launch direction due to torsion in the cable. So the suspension cable has got torsion in it. I can feel it. It's very hard to measure, but obviously it returns to some position. Now the only way to measure that is with the bob, so I'll just reassemble the bob and just see if we can measure that. So back to my little measuring this small little bit of wire that I've used. Right, our Z angle is now minus 59.9.60. Now try and move the it is possible to move the torsion in the pendulum bob with this small piece of wire that's almost the thickness of a hair. So that is our resistance of the torsion in the bob. Almost insignificant to overcome. See if I can bring that around to minus. By wiping that I can get that to turn around. But that tiny bit of wire can actually move it. That's okay. I can't figure this out. It's just what's going on here. Almost insignificant amount of the torsion is, yeah, it's immeasurable, I guess. But it is there. Now maybe that's what we're looking at. I don't know. Alright, the only thing to do now is do a run and see if we can repeat our same results. So stand by for the setup for the next run. So our bob's hovering around that 40-degree mark, 44. So let's do a launch. Right, we're on track. Our cable's illuminated. I'll swing around so you can get a better look at that. Looking good. Cable's illuminated in the centre. Remove that launch magnet. The bob, as it approaches me, is being illuminated in the centre. Now our indexing mark is obviously gone off track there. It doesn't matter because we now have our angle. Our Z angle is 40.69870. It's still, that's 40 degrees. And our pendulum You're just starting to... No, I don't think it's processing yet. Still at 40 degrees. Not too happy about our roll, the y-axis there. Oh, fluctuating 1 degree. Oh, that could explain why the pendulum is actually precessing. That wasn't as bad last time, I don't think. Obviously our x-axis, which is the pitch, is pitching a few degrees, which we expect, tilting up and down. You might notice those other parameters there are the acceleration of the x, z and y axes and their angle, and I really have to put that in an Excel spreadsheet before I do anything with it. I can't really pick that unless you put that in an Excel spreadsheet and map it. Interestingly enough, our torr of our magnetic is at minus 33, 31, 29. I guess that's corresponding to the angle, the Z angle as well. Let's have a look at our... Everything still seems to be very little precession at this stage. Ooh. What are we in, about 4 minutes in? 5 minutes, coming up to 5 minutes. Actually the time on the camera says 5 minutes, but I don't think that was my launch time. Anyway, not too worried about that at this stage. I might just turn the lights off. I'm up in my lounge room at the moment because the lab got a bit overcrowded. What? Let's see what's happening now. What we're really looking for is that laser as it approaches me. Where is it? Is it still in the center? Looks like it's still in the center. Coming towards me, center. Coming towards me, the cable is illuminated. Coming towards me, cable is illuminated. So to me, the pendulum is not processing any way at all. We'll give it some more time. .41 degrees on our angle, Z angle, and we've dropped off our X angle. It's no longer a little bit of change in our X angle there, which means that it's still pitching a tiny bit. I think we're now approaching a cosine. Cosine is when the length of the, if you imagine the swing of this pendulum as a right angle triangle, the opposite and the hypotenuse lengths are about the same. So I believe that is the correct method to run your pendulums. I believe that Foucault also did that as well. He's remember his was 69 in Paris, 69 metres long, and it had about a 10 metre swing. 1:7, I think, something like that. Still if I was to have a guess, I would say that pendulum is precessing clockwise. I'll just swing my laser around to measure that. Yeah, we have a clockwise. Our pendulum now is precessing clockwise. Welcome to the world of the Foucault's pendulum. The inconsistencies of this device is very frustrating. Yes, I can guarantee that now that pendulum is precessing clockwise. Yet our Z-axis, the bob, has not changed. So it is still at the launch angle. So if this was in the northern hemisphere and you're running this experiment, you'd say, oh, look at that, this experiment's running fine. Let's have a go at see if we can measure this angle so far. Put some more light on there if the camera won't focus. It's 17 degrees up here at the moment. Alright, that's definitely clockwise. Okay, that's it there. I've just moved around. Our laser coming towards us is hitting the cable. Yep. Let's take it up the other end and show you what actually happened. So that's the offset. That's where it was, and it went clockwise that direction. Alright, too far. Yeah, back to it. Okay, as it comes towards me, the cable has to be, that's it. The illumination of the cable as it comes towards me is the original launch angle. So the pendulum has actually, absolutely without question, has precessed in a clockwise direction, which would be correct if it was in the northern hemisphere. However, we're in the southern hemisphere and the pendulum should have gone anti-clockwise or counterclockwise. And our original launch angle is round about that 40 degrees mark. It hasn't changed. So maybe the torsion of the cable is the reason. Nevertheless, there is an inconsistency. Just by changing that, unplugging that suspension cable and reinserting it, has upset something. Unbelievable. Alright, I think that's enough of this. Again, we've got inconsistent results as far as the swing of the pendulum goes, but we certainly got consistent results as far as the bob is concerned. So what I might do is just stop the video and regroup again for another experiment in a couple more days and see if we can figure out what actually is happening. Okay, well, thanks for watching and see you in the next video. Well, I just thought I'd catch the dying moments of this setup. Clearly the pendulum is now swinging clockwise and the angle is quite pronounced, and our bob angle is still 41 degrees. So basically, if you can look at that difference in the two boards, that's roughly our angle that it's processed during that time. This gap down here, the board is stationary in the bottom and this is the swinging board on top. It gives the angle. Alright, thanks again, see you in the next video.